Hey guys, we're going to continue our conversation about composition of transformations, but before we do, I'd like to ask, why did the obtuse angle go to the pool? Because it's more than 90 degrees. Awesome. Thanks, Shelby, for the great joke of the day. So what we're going to do here is I have two lines, and I would like to um, first reflect this triangle across this line and then reflect it across this line and see what happens when I do two reflections, a composition of two reflections. So first I'm going to reflect this triangle ABC, and you see it lands here. Just to kind of rename these points, you can see that the orientation is opposite, right? Like this triangle is pointing in the other direction. Now if I make this my line of reflection, and reflect the image, it lands over here. And I don't know if you can see this or not, but A double prime, B double prime, C double prime is back in the same orientation, right? If I count clockwise, it's ABC. But there's something else going on I'd like us to investigate. Okay, the actual transformation that has happened is a rotation. If I were to rotate this triangle around here, I want you to check this out. So the angle here made by the two lines of reflection. So I just measured this angle right here. This is 43.84 degrees. Okay. If I were to take, I'm going to change, if I were to take this triangle and rotate it, I have to name a center of rotation. If I were to rotate it around the point where the two lines of reflection intersect, let me show you what will happen. Obviously, if I were to rotate it, then the angle formed by B and this point and B double prime, if I were to measure that angle, that would be my angle of rotation. So it says here it's 87.68. If I try it with A, it should be the same angle, and when I measure it, it is. And I'm just for good measure, I'm going to do it with C as well, right? And so obviously this is my angle of rotation. And I don't know if it's obvious to you right away, but this angle of rotation is related to the angle that was between the two lines of reflection. And if, in case we aren't able to see it, what it is it's this number times 2. I'm going to show you this. If I take the angle between the two lines of reflections and double it, that is the angle of rotation that happens. And if I change where the lines of reflection are, notice that this is always happening, right? So what we're seeing here is that reflecting over two lines that intersect is the same as rotating by twice the angle that's in between them. It doesn't matter how large that angle in between them is. Okay, I want to show you another example of this. Okay, in this case, these two lines that I have right now, they are intersecting at an angle of 39.5 degrees. Okay, so that's this angle EFG. This time I have a little quadrilateral that's inside my two lines. So what I'm going to do first, I want to reflect it across this bottom line. So if I reflect this figure, it's obviously going to land down here. Okay, if I take this bottom figure, my image here, and reflect it across this line, it's going to land way up top. Okay, and so just to kind of prove my point here, the angle from A to F to this angle should be twice 39.5, and if I measure it, so that should be just under 80, right? 79. And there it is, it's twice as much, right? If I try it with B, same thing happens. Okay? Whoops, I need to measure this angle. Same thing happens. And so even if the figure that I have is inside between the two angles, same thing would happen if it were above the two angles, right? Because it's going to reflect over one and then back over the other, it still has the same property of a rotation. Okay, and so if I were to like delete this whole figure and get rid of it, and I just try taking this and rotating it around this point by, in this case, say like twice this angle, so 44.96 it's going to land right where it was when I did the two reflections. Hopefully you saw that, and you can rewind it if you need. So this is a really important deal here. When I have two reflections, it's the same as a rotation if those two lines of reflection intersect, okay? And the angle of rotation is twice the amount of the angle between the two lines. So just to take that over to the coordinate axes, we can see, what if I wanted to reflect a point across the x-axis and then across the y-axis? Well, that means I'm reflecting across this line of reflection and obviously the y-axis, and the angle that those two form is 90 degrees, which means that reflecting those 2 points should be the same as a rotation of 180. And if I check that out, right, if I go reflect over this line, it would land here at 4,2. If I reflect over the y-axis, the x-coordinate is what becomes negative, and it should land over here, right? So my point here that was 4, -2 becomes the point over in the other axis, or in the other quadrant, I should say, of -4, +2, which matches what we would expect for a rotation of 180, right? XY turned into the point, and sorry for my handwriting, XY turned into the point -x, -y, okay? And that's exactly what a rotation of 180 is. And you could see this if we did the rule one at a time as well. And I'm going to be fast if I type this, okay? Right? Because I would have the point XY. If I reflect over the x-axis, oh boy, then I would make the y-coordinate negative. And if I reflect over the y-axis, I would make the x-coordinate negative, which results in what we got here. I want to look at one other scenario here. What if I reflect over a line, two lines, but they don't intersect? What if they're parallel to each other? So what if I have these two parallel lines that I reflect over? If I take this arrow and I reflect it over that line, it's going to land right directly upside down. Okay, so there's my image. But if I take this image and reflect it over this line, it's going to be pointing the right direction again. Right? And so no matter where I move this line, right, it's always going to have opposite orientation, then the same orientation. And I don't know if you can see what's happening, but this ends up being kind of the same as just a translation. Okay? So what's happening here is two reflections when the lines intersect equals a rotation. But when it is two lines that are parallel, all I've done here basically is taken this original image and slid it up to here. Okay, let's look at it in the coordinate plane and show you what I mean. So right here, what if I reflect across y = 2 and then y = 7? Okay, so I went ahead and sketched the two lines. So let's say I have a point right here at 5, -3. If I reflect it over the line y = 2, right now it is 1, 2, 3, 4, 5 below. So if I go up 1, 2, 3, 4, 5, it's going to land right here at 5, 7. And when I reflect it across y = 7, it's not going to go anywhere. Okay. Let's say I had another. Let's draw a triangle here. Okay. If I do so, this was A. Okay, and here's A prime. All right, if I tried this point, it's at -4, so reflecting it over 2, that's 6 away, so I need to go 6 above 2, which would land here. And then when I reflect across the y = 7 line, it's going to land here at 6. Okay, so that would be our B prime, if this were the point B. And C is at -5, which is 7 below 2. So if I go 7 above, it's going to be up here at 9. But then I would need to reflect over 2, which is down, or over 7, which is down 2, which would bring C to down here at 5. Okay? So if you're looking at these numbers, 3 went up, -3, a y-coordinate of -3 landed on 7, a y-coordinate of -5 landed on 5, a y-coordinate of -4 landed on 6. Right, so each one of these, you can see the orientation is the exact same. What's happened is my triangle has just slid up by 10 units. It's a translation of 10, okay? What's the distance between 2 and 7? It's 5, and double that is 10. Okay, so what's happening here is this distance, just like we would expect when we reflect, the distance between here, which was 5 units, if I double that and translate, that's how far of a reflection it is. Okay, and so this is not a coincidence. Just to kind of summarize what we're talking about, if I have two lines of reflection and they intersect, whatever this angle is, okay, then reflecting across both lines is equivalent to a rotation that's twice this angle. If I have two lines of reflection that are parallel, then reflecting across both of them is equivalent to a translation of 2 times the distance between the parallel lines. And we're going to play with this tomorrow a little bit with some examples, but that's kind of the end of the unit in terms of new material. We just need to get better at practicing this stuff and applying it to the coordinate plane.